In this video, we're going to look at solving some trig equations that deal with identities. Now, I have some identities here. We definitely don't need to use these. This will be the one that we're using, but I have it here because these are the double angle identities. These are the ones I almost never remember as well. But the one I do remember is the Pythagorean theorem, which is a squared plus b squared equals c squared. And in this case, if I were to make like a right triangle, let's say right here, well, my a and b are the x and the y, which is just the cosine and the sine. So we could say cosine of theta square, cosine square theta, plus sine square theta is equal to, right? This is my cosine, that's my sine. Well, if you square this and square that, the Pythagorean theorem says that you will get the hypotenuse squared. In this case, since this is a unicircle, I know my radius is 1. Right? 1 square is still 1, so I don't have to write the square there. But this is the other identity that you should be fully aware of and know how to come up with. So let's use this to solve the problems. Just erase that. Okay, so for A, I notice that we have a cosine in both of them. So let's factor out a cosine of theta. And we end up with 2 cosine theta plus 1, right, equals 0. And if you don't understand what I did was I just kind of like saw that there's a cosine in each of them and I took it out. So I want to write it like if I need to distribute it, would I be able to get that thing back? And if I distributed this cosine over here, I'll get 2 cosine squared because the cosines multiply. So 2 cosine square theta. If I multiply this cosine by that 1, I'll get exactly that. So all I did was I undid the distribution that's there. Okay, so if you have 2 things being multiplied to give you 0, then that means one of them must be 0. That's the only way we could get 0. So we could say cosine of theta is equal to 0. And we could also say 2 cosine of theta plus 1 is equal to 0 as well. Now, what angle is cosine of theta equals 0 for? Well, that's where this handy unicircle comes into play. And thankfully, we're only focusing on the interval 0 to 2 pi, right? Which this circle encapsulates. So what angle is cosine 0? I see cosine is 0 at pi over 2. So theta could be pi over 2. Where else is it 0? It's 0 at 3 pi over 2. It could also be 3 pi over 2. Well, let's see. Minus 1 on both sides. So we get 2 cosine theta is equal to negative 1. Divide by 2. So cosine of theta is equal to negative a half. So let's go back to a unicircle, see what angle cosine would give us a negative a half. And you know, I'm using this as though you know to use it. If you don't know, the first number here represents the cosine, the second number is a sine. So cosine of the angle is negative a half. Let's see. So cosine is negative over here, so that's 2 pi over 3. All right, so theta could also equal what I said was 2 pi over 3. And where else is cosine negative? It's over here as well. 4 pi over 3. All right, I'm not going to rewrite these nicely, but these are your solutions. You have 4 of them. Let's do B. Okay. So the second I'm seeing this, I'm thinking, okay, I need to convert either the cosines to sine or the sine to cosine. Because I know this identity right here, I could convert that cosine to sine. So I'm thinking about it as minusing the sine square on both sides, right? So all I'm doing is I'm minusing sine square on both sides. So I'm going to get 1 minus sine square theta. So now I know what cosine square theta is equal to. I'm literally just going to replace this with it. This is 2 1 minus sine square theta plus sine theta, notice that this one is not square, is equal to 5. Let's see, what can we do here? Let's distribute that too. Now, it's not equal to 0, so I'm going to see if I could get it equaling 0 or something. Because it's a quadratic, once you see a square and a non-square, you could try to solve it by factoring or something. So let's distribute that too. 2 times 1 is 2, minus 2 sine square theta plus sine theta. I'm going to minus 5 on both sides because I want it equaling 0. I'm just going to combine that 2 and that negative 5. So we get negative 2 sine square theta plus sine of theta minus 3 equals 0. Now, it might be smart to try to see if we could factor this. I know there's a pesky number in front of this thing, so that kind of like changes the dynamic a little bit. But I tried and I couldn't do it. It seems like I could get closer, but I couldn't. So let's just use the quadratic formula. And I'm going to think about my x as being sine square theta, right? You don't have to like substitute it like this. I actually did this in my mind, but because I'm doing a video, I'll write it down like that. So I'm thinking of this. Let's put it in a cloud so you know that I'm thinking of it. So I'm really thinking of this as negative 2 x. I'm sorry, x is sine, just sine without the square. So negative 2x squared plus x minus 3 is equal to 0. So now hopefully with this little substitution thing I did here, you understand, like this is just a basic quadratic. Let's use the quadratic formula. X is equal to negative b plus or minus the square root of b squared minus 4ac over 2a. How did I know that so quickly? I looked at the tattoo on my arm. Let's substitute the numbers. So for b, this number is b, the number in front of that is b, so that's negative 1 plus or minus the square root b squared, so that's 1 squared, which is just 1, minus 4 times a is negative 2, times c is negative 3, all of that over 2 times a, which is negative 2. Now I'm seeing something here. Negative 1 plus or minus, let's just put this all over negative 4. Now 4 times negative 2 is negative 8. Negative 8 times negative 3 is positive 24. So I'm actually getting the square root of 1 minus 24, and that's a problem because in this entire course we're dealing only with real numbers, and in the real number space we cannot take the square root of a negative, and that's what's going to happen right here. You'll have 1 minus 24, which is really negative 23. So let's just erase that and put negative 23. And we can't do that. We can't take the square root of a negative, not in this real number space that we're working in. So I'm going to have to conclude that for b, there are no real solutions, or just no solutions. Okay. C, let's do C. Hopefully I have enough room right here to do C. Don't know why I boxed myself up in that room, but I have all this room here. So C, 2 cosine theta plus 2 sine theta is equal to 2. Now I see there's a 2 being multiplied by everything, so we could just go ahead and divide everything by that 2. Get that out of the way. So you end up with just cosine of theta plus sine of theta is equal to 1. So what could we do here now? Let's see. I'm looking at this. let's see if we could we could rewrite. There must be something we could rewrite here. Now it's really close to this, but it's not that. So you know what? Let's separate them. Let's do cosine theta is equal to negative sine theta plus 1. Right? All I did was I minus sign on both sides. Why did I do that? So that I could square it. In fact, why bother doing that? Let's just square both sides right here. Right, I'm just trying to see if I could get you know, I just want to see if I could get something like that, like a square term somehow, even though I'm going to end up with a middle term. Now, hopefully you could kind of do this in your head. And if not, well, like, I guess let's just do it right here. Cosine of theta plus sine of theta. We want to square it, so that means we're multiplying it by itself. Cosine of theta plus sine of theta. So cosine times cosine is cosine square. Right, so that's that. Cosine times sine is cosine of theta, sine of theta. Now, I have to do it again right here. Sine times that cosine is cosine theta plus sine theta. And then the sine of theta times that sine is sine square. Didn't want to write on that, but okay. So basically, these two terms here are the same in the middle, and we could combine them. And we end up with cosine square theta plus 2 cosine theta sine theta. It doesn't matter if you wrote sine theta first and then cosine theta, plus sine square theta is equal to 1. All right, so now let's see what we could do here. Now, I see something. I see something right here. See this? Look at the identities. 2 sine theta cosine theta. That's what this is. 2 sine theta cosine theta, all being multiplied. This whole thing really just converts to sine of 2x. Now remember, I started off thinking, oh, let's try to get something like that, but there we go. And I knew this in advance, I just didn't remember it. And here we go. We have the sine square theta plus cosine square theta. Well, what do we know that's equal to? Cosine square theta plus sine square theta is 1. So this, all that just this piece here just converts to 1. So that's equal to 1. Minus 1 on both sides. And we get sine of a double angle. I don't know why I wrote x there. Theta is equal to 0 because we're minusing 1 on both sides. Now, here's the thing. You could do this in a couple of ways. I'll do it algebraically, but I'll also show you using this picture. Right? So what angle? I know this is like twice of an angle because theta is really the angle. But what angle would sine have to be to give us 0? Now, sine is 0 right here, right? So we could say that 2 theta is equal to the angle to 0. If, and in this case, the angle itself, right, you just divide both sides by 2. The angle itself is 0. Right, 0 divided by 2 is 0. So that's one angle. But that's not the only place where sine of an angle is 0. You can see sine of this angle over here, right? And I'm not going to say the 180 degrees because we're thinking in terms of radians here. I'm going to use a pi. So that double angle could equal pi, right? And divide both sides by 2, and you get that theta is equal to pi over 2. Is there another place where sine of theta is equal to 0? Well, not in this interval, right? And honestly, if it wasn't for this interval, you just have to add another 2 pi or like subtract another 2 pi and look at the circle that way. And I know that just went over your head, but that's okay, right? We're just focusing in this interval. So for this one, you have two answers, and that is it.